Welcome to the shop. I'm continuing to make parts for NQALHA Production Run 4. There's 750 parts to make, so I'm gonna get going. In the previous videos, I've been making the more complex and difficult and larger parts, and they're mostly done. I've got a couple of interesting parts coming up, but today I'm going to be making small parts. And you might think that, well, it's small parts. They must be real easy and fast, but all parts are slow, even the small ones, mostly because just of the tool change time on the Tormach is so slow that sometimes the machine takes more time changing tools than it does actually cutting. I'm trying something new today, having had success with the little bogies in a previous video. I'm trying a scheme where I use the stop on the right side of the vise and put two little parts, one on the left and one on the right, in the vise. And this, I believe, is going to have two benefits. First of all, the vise, even though it's a nicely made vise, if you try to clamp a tiny little part on one edge, well, the vise does twist a tiny bit, and it's always nicer to have something on the other side to kind of equalize it, to make sure that the jaws are pushing equally on both sides. And so even though I can make a single small part in the vise, it's a teeny bit better for the vise and for the part to have the clamping force balanced. The other thing, of course, is I get twice the production rate with the same number of tool changes. If I really wanted to go crazy, I would put a right-hand stop on the left vise, load up 4 parts at the same time, and then create a tool path for that. But there's always a trade-off. How much time do I spend dicking around perfecting tool paths, and how much time do I spend just machining? And so I kind of like weighed the evidence and judged a compromise that I'm going to try on the small parts just to use right vise only, 2 parts per cycle. So once again, this is a known trusted tool path, but it's been modified for the left and right, and we'll see how it works. It should work really well. Also, as in the more recent videos, I've done all of the machine setup ahead of time. I've loaded the tools into the tool changer. I've set the 0 point of the machine, X and Y 0, using the Heimer indicator. For this part, the Z0 is set on the ledge of the soft jaws, which effectively is the bottom of the part. If anybody is interested in seeing the setup, my first 2 videos go over setup in detail. And actually, having gotten this far in the video series, I'm planning to make a dedicated video on Tormach tips, tricks, and pitfalls, because after several years of using this guy and making several thousand parts, actually, successful parts, I think I have some knowledge that probably is worth sharing. So let's get the machine going and see how this works. It should work just fine, but there's always surprises in CNC machining. Gonna drill a hole first. The hole, and nothing but the hole, so help me hole. Okay, we're stopping at the correct pre-feed height, and then dropping down to, yeah, that actually looks roughly correct. A little surprising there. And then, yeah, that looks kind of correct. And we're rapiding to what appears to be the correct place. The hole is not going all the way through because when the part is flipped and another machining operation is performed, the second operation, let me stop talking for a moment and pay attention here. Okay, when the part is flipped, the material will be machined away on the other side, so the hole only needs to go through about 1/8 of an inch of material. Bobcat is somewhat mysterious to me, how it chooses where to the various different rapid increments, what I call the pre-feed height, and I suppose if I spent some time studying it I could figure it out, but for right now it just has been a bit of a mystery. So feeding, cutting, moving, feeding, cutting. And once again, this cut is, it doesn't go all the way through the 1/2 inch blank, but when the part is flipped up and the second operation is performed, when the metal is removed from the top surface, both the hole and that little slot, or the profile, edge profile, will end up being cut all the way through the remaining 1/8 inch piece. So, boy, that wasn't very interesting, now was it? I'm gonna run these parts, turn the camera off, flip to the next operation, show the next operation, and then probably, since these guys will go real fast, I'll just make little parts all day. And, you know, how exciting can that be? So, see you later. Okay, first operation has been completed. I've got the parts now sitting end up in the vise, left and right stops. And one thing I didn't mention in the first part of the video, these parts are cut to length on the table saw. I didn't show that part because I just don't feel like, it's not that exciting, and I didn't feel like carrying the camera over to the table saw. But I use a precision fence, a precision miter gauge, WD-40 as a cutting lubricant, a thin kerf aluminum blade, and a digital readout. And with very careful operation using a push stick, I can cut parts with a decent surface finish and extremely good accuracy. When I checked these guys with a caliper, they were within like 3/1000ths of spec, and the length that I was cutting isn't even that critical anyway, but it's surprising how, and it's a high quality table saw. It's a really nice rigid table saw with a cast iron frame and a cast iron table. And it's kind of surprising how accurately aluminum can be cut. And about the only thing that I had to do after that was a little bit of deburring on the Scotch-Brite wheel. So, gonna try the second operation now. This is gonna be drilling some reasonably large diameter holes, slightly under 3/8. And this is gonna be part of the conduit assembly. And the conduit assembly is somewhat complex. It's nominal 3/8 diameter, although it's a little bit under. That's why I'm using a slightly smaller drill. It's steel, galvanized steel flex conduit, what they call the super flex conduit that flexes really, really well. It's really limp. And there are 3 aluminum pieces that attach to the conduit. 2 of them attach with epoxy, forming a kind of a permanent assembly, and then one of them is just slips over the conduit to hold it in place. This is going to be what I call the dual conduit clamp, so it's got 2 holes and a bit of relief. And let's see if the gang tool path actually works. Single block mode. Looks like it's stopping in a reasonable place. (1500 RPM, 10 inches per minute, fast peck cycle. Forget what per peck depth I'm using, probably 70, 80 thousandths or so. It's making nice thick chips, short, thick chips, which oh, look at that, works perfectly. I prefer short, thick chips because they don't wad up on the cutter. And the way to achieve short, thick chips is slow down the spindle RPM a little bit, turn up the feed rate a little bit, and peck. So drill bit comes out perfectly clean. Now, I'm going to switch to the milling cutter. 1/2-inch Lakeshore Carbide 3 flute, finish milling cutter, straight flute, and I'm going to be cutting. Oh boy, that there's coolant everywhere. That 1/2-inch cutter. It just flings the coolant. But it looks like all is working correctly, as long as I stay out of the line of fire. (5140 RPM, 10 inches per minute. Doing this in 2 passes to cut away a 1/2 inch of material, and successful completion. Well, there sure is a lot of coolant on the floor. My custom-made splash guard works really well for most operations and contains the coolant most of the time, but for some operations, and looks like I need a little bit, this definitely is fixable on the sander, but the little remnant left over at the top, I should have cut a slight bit deeper with the 1/4-inch tool. But anyway, that's what the part looks like. Not very exciting, but successful and necessary. So even the unexciting parts are necessary. So I'm going to load up another couple of parts, run the batch. The third operation is even less interesting than the first two, and I may not bother showing it on camera. It's putting a little bit of a countersink on that drilled hole, and I'm not sure it's worth showing. I may or may not show it, but it's a countersink. I mean, you probably know what it looks like. So I'm going to finish running this batch and then load up another set of parts and just make little parts all day. So I'll be back. Actually, probably should do that in an Austrian accent. I'll be back. On to the next part. And this one is even less interesting. The little parts, they're really not that interesting and they're not that fun, but they're necessary and they take way more time than they should given their size. Once again, got 2 parts in the vise, cut to size on the table saw, surprisingly accurately, and I'm gonna drill some holes. Should go well. The tool change takes longer than the drilling. Stopping in the right place, feeding in the right place. With a simple tool path like this, there's very little chance of things going wrong. Boy, wasn't that exciting? The hole, and nothing but the hole, so help me hole. So I'm going to run these. Second operation isn't a whole lot more exciting, but hey, at least I'm ticking them off my list. Every little part is an essential part, and they all have to be made. So see you later. First operation on these little guys is complete, and when I started thinking about the second operation, I kind of changed my plan a little bit. If I wanted to use the 2-up gang, I'd have to make a gang tooling plate and then have to go on the lathe and turn a little spacer, because that hole is slightly under 3/8, so I can't use a 3/8 screw. I have to use a 1/4-inch screw with a shoulder spacer, and I figured that the time it would take to make that new tooling plate is way more than just running with the fixture I had. So I'm going to be using the old tooling plate, and at least I don't have to have a tool change for this operation. All done with the same cutter. So pretty uninteresting, showing it just for completeness, you know? Some people might want to see every part being made, so. Okay. Wrong tool path. Single block. Stopping at the right pre-feed. Stopping at the right feed. Can probably speed that up a little bit. It's doing the entire 1/4 inch in one pass, but since it's not cutting a slot, the chips have plenty of clearance, so probably go ahead and speed that guy up a little bit and put a move to unload at the end. But hey, this is probably the least interesting part in the entire sequence. But it's necessary. Can't work without one, so I'm going to run that and then make another little part. And we'll just have little parts aplenty, an abundance of little parts today. So see you later. And now, here's an even simpler little part. Almost not worth videoing, but hey, gotta be complete. Gotta show it all. Well, not quite all. Almost all. So let's drill some holes. Got 2 little parts. Cut on the table saw. Clamped in the vise, left and right. Gang operation. Let's drill a hole. Yep, that's it. At least I don't have to suffer through a tool change. First operation complete. And if you're hoping the second operation is more exciting, well, it does have a drill and a tap, so I guess that's a little more exciting. I'll be back. The run of little parts continues with the second operation on this guy. This operation has a drill and a tap. Ooh, that's exciting. Okay. Should work real easy. Should be no problem at all. And yeah, that looks reasonable. Peck cycle, 5,140 RPM, 10 inches per minute. Going to be doing an 832 tapped hole. And yeah, if I didn't want to suffer through the tool change, I could probably tap it by hand, but the pieces are pretty tiny and can't really hold it in my hand and tap it, so. Of course, there's always the question, am I driving myself crazy trying to eke out the last little bit of efficiency on a part that's already really fast? So. Tap magic. Tap it good. So that another almost completely uninteresting part. But it's essential. Can't build an NQALHA without one, so I'm going to run the batch and then probably make another little part. Going to be the day of the little parts. So see you later. And the little parts just keep on coming. So here's another one. These are going to be thumb wheels. And now they're going to get holes. Wow. Hard to imagine anything more exciting than holes. Although the outside, the profile mill is kind of fun. And, you know, even little parts are necessary. Here we go. 1/4 inch hole. Should be no problem. So, boy, that was exciting. So now I need to decide, am I going to make a dual gang tooling plate? And yeah, it's just 2 holes, so I probably will. I'll make a dual gang tooling plate for this guy, and the profile is ever so slightly interesting, but not that interesting. Then it gets a perpendicular drill and tap 1032 for a set screw, and little bit by little bit, the little parts keep on coming. See you later. I made the tooling plate off camera. Wasn't that interesting, just a couple of holes. And so now I've got the first operation parts screwed down with 1/4-20 screws, aluminum washers, gang operation, known trusted toolpath, but this particular combination has never been run, so treat it like it was new. Same old, same old. And here we go. So, got to let it know what tool I put in. I'm going to be roughing it out with the aluminum shredder, and then finishing with a 1/4-inch end mill. And I'm thinking that I have a problem here. I'm thinking that I potentially, without even single stepping through it, just thinking about it, if I cut the rough here, raise up and wrap it across, I'm going to hit that screw. So hitting that screw would be a really, really bad thing. I'm going to go to the CAD room, make sure I'm okay. Looking reasonable. Yeah, no problem. Since the part is only held with one screw, I don't want to get too aggressive, because even though aluminum against aluminum has the highest coefficient of friction of any metal, and I've got an aluminum spacer on the screw, and I tighten the screw pretty tight, I sure don't want that guy spinning, so I'm kind of somewhat taking it easy. And that looked really good. All is well. Quarter-inch end mill for the finish cut. And that looks entirely reasonable. Let me, yep, got the hand on the stop button, ready to stop it before the rapid destroys my cutter and my screw. Screws are cheaper than cutters. And yes, I've made that mistake before. So, probably add a move to unload position, and here is a thumb wheel. Got a kind of a nice little profile on it. I'm gonna kind of like hit it with the Scotch-Brite, because this is something that a finger comes in contact with, and I might want to make it nice and smooth. So that's the second operation, and I'll be working in parallel after I turn the camera off, but just to show, well, what comes next, I'll go over to the Bridgeport and change parallels. Yeah, I'm going to be drilling a a 1032 hole for a set screw. So there's our set screw hole, and this one gets tapped by hand on the cordless drill. So, little part day. They may be little, but you can't build an NQALHA without one, or without them, I should say. Every single one is necessary. So, I'm not going to show the Scotch-Brite operation. You can probably imagine what that looks like. And I don't know. I'll probably make another little part. So, I'll see you later. Well, small parts day continues. Got another one coming up here. This is going to be the clamp lever, and it's going to be done in the standard left and right vise, one part at a time, because the part is long, so I can't use that gang scheme. The tooling plate is slightly complex, more than just holes. It's got like a little spacer thing and a little clampy bar thing. And the first operation is just a hole, and the second operation is a profile. Third operation is drill and tap and clearance. Fourth operation is a slot on the Bridgeport. Known trusted tool path. Should work just fine, but you never know, so I'm gonna be careful through the first time. Half-inch drill bit. Work offset 1. Pre-feed looks correct. Feed looks correct. No, it doesn't. No, it doesn't look correct at all. I'm wrong. Let me go check that. The tool path, let's see. Oh, yeah, I don't know why I would do that, but what's faster? Putting in the electronic tool setter or changing the tool path? I'm going to reference to the top of the part. I'll be right back. So what was going on there? Sometimes I reference from the top of the part, sometimes I reference from the bottom of the part. Sometimes there's a good reason for choosing the reference, and other times there's no good reason. And this is one of those times where there's no good reason, and I kind of confused myself a little bit because I referenced the machine to the top of the part, but the tool path was referenced to the bottom of the part. So let's give it a try. And that is pretty much not correct. That is terribly not correct. Horribly not correct. That's what I get for talking and not paying attention to my work. So that is very bad. Very, very bad. I'll be able to finish this part today, but I'm going to have to make a new soft jaw eventually. Very, very bad. Did I say very bad? Very, very bad. Why? Why? Simple parts will make you crazy. Here I am. Okay, 0 is correct. Here I am saying, oh yeah, this is simple, this is boring. Known trusted toolpath, can't possibly be wrong, and yet it was. Back to the CAD room. That was stupid. Okay, today's lesson is don't be stupid. That was stupid. That was really stupid. Let me tell you how stupid that was. My normal tooling plates have the part at the same 0 as the tooling plate. So it doesn't matter. Part 0, tooling plate 0. This is a special tooling plate. I completely spaced out and forgot that this tooling plate, because of the clampy thing in the back, its 0 is in a different place. So, stupid, stupid, stupid. I hate being stupid. My least favorite thing. Well, other than pain and failure. I hate pain and failure too. But being stupid? Ah! Okay. That looks substantially less stupid. That looks massively less stupid. So, when I go into production, I'm going to be using the combo tool path, but right now, I'll probably just run the second operation while the camera's going. Did I mention I hate being stupid? So, part goes in here, little shoulder spacer. Gotta have a move to unload in there. So, this one also has potential to bite me with all these protruding screws. And yeah, you know, it was a known trusted toolpath, but I must have tried optimizing something or tried being clever and ended up getting bit. That's the problem with memory. I'm going to be moving over to the aluminum shredder, work offset 3. And that is actually looking somewhat non-stupid. And yep. And yes, that is sufficient clearance. (5140 RPM, 40 inches per minute). The aluminum shredder, 3-flute roughing cutter, serrated flute, makes really, really fine chips. Flood coolant washes them away nicely. No problem with chip evacuation. So at least that was correct. Quarter-inch end mill, 3 flute, Lakeshore carbide, 5,140 RPM, 30 inches per minute, doing the finish pass, and doing it successfully. So, did I mention I hate being stupid? There's the part. Next operation is going to be a perpendicular drill from this direction, followed by a slot from this direction, forming a kind of a little clampy fixture here to clamp this arm on the cam, the axle of the cam that performs the locking operation. So, oh well, into the scrap aluminum bin. Fortunately, I have plenty of extrusion. So I'll come back, turn the camera off, come back for the third and fourth operation, and hopefully not be so incredibly stupid. Did I mention I hate being stupid? So after an annoying piece of stupid, first and second operation on the clamp lever is complete. Parts look nice. All is almost well, except for needing to make new vice jaws. But they were getting kind of dinged up anyway, so probably isn't that bad. I've got a CNC program, and I just whip them out. And I've got the material. So the third operation is going to be a drill and tap, a clearance drill, a tap drill, and a tap, and it's also a known trusted tool path. And of course, as I was setting up for it, I remembered, oh yeah, that's why I referenced from the bottom of the part in the first operation, so I could go to the third operation and not have to change the Z reference. Memory is terrible. All these, no matter how much I write down, I still don't write down enough. And obviously, when I'm in the middle of the process, no problem with memory. I just know what to do. But, 6 months later, 8 months later, memory is out the window. Let's see if this one works. It worked the last time I used it. Yeah, the pre-feed looked a little weird on that, but Bobcat is kind of inconsistent with its pre-feed. Sometimes it's an inch above the surface, sometimes it's not, but looks like the hole was drilled correctly. And that looks fine. So next, gonna be tapping. it's actually looking pretty good, so a little bit of tap magic here. Give it some magic. And we have a hole. Nicely tapped hole. So I'm going to be doing the fourth operation in parallel, but just to get the video finished up here, this is what the part looks like. And now it's got its hole. And I'm going to cut a slot. I'm going to cut a slot right there on the Bridgeport. And the setup sheet says 3/16 from the face. So I'm going to grab a parallel. I'm going to cut this one by hand. But even by hand, I still use the DRO. And slow down and I'll take a look at it, and sure enough, looks correct. And that is the part with its little slot. So I'm going to finish running parts, call it a day, edit the video, and thanks for watching. It's been mostly fun except for the stupid part.